As I was mentioning prior to that interruption, one thing that's very interesting is to look at say a baseball that comes in, has a momentum P, that would be mass times velocity, and when it's hit by a bat, it goes back in the opposite direction. You have to understand that if this is the P initial and this is P final out in this other direction, that this P initial and the P final, we take the difference of those, the difference of the P's. However, one of these is negative. If we take this direction, for example, as being positive, then be P initial minus, and now P final is in the other direction, minus a P final. So it always turns out that this is P initial plus P final. And so we have to understand that this difference involves the negative of one of these. Now this is very pertinent when we look at rain hitting a car versus hail hitting a car. Here's I'm going to draw a car here. And now as we have rain that comes in, as the rain hits and disperses, then of course we only have the P that's incident upon the car, since the rain disperses and the rain just doesn't bounce off in any direction. It just randomly goes in different directions like so. So the impulse from rain is just going to be the P initial from the rain that's falling. However, if you have hail that falls on your car, then the hail will actually bounce. So in fact, if it bounces, and also hail usually has a higher momentum because it's larger than a raindrop, it's frozen and can be the size of a golf ball. So not only is this incident momentum huge, the final momentum is in the opposite direction as this thing bounces off. So in fact, it's almost twice as great because of the recoil of the hail, and that's what damages a car from hail more than rain, other than the fact that hail is much larger. And so both of those are pretty straightforward to calculate. The same thing goes for a golf ball. You can look at the impulse when a golf club hits it. Here we're only looking at an initial momentum of 0, and then when the club hits it, swings through. Again, we do have this very complex force, and so we could look at the impulse and say, how much momentum did it end up with? Because the initial momentum is 0. And whatever that momentum is that it finally has, P in this direction, that P is the change in P. And so that change in P is going to be the average force exerted over a certain amount of time, delta T. And the problems that we would have here are just simply looking at what the initial and the final momentum are. The initial and final momentum for hail is the same as for a baseball. They're going to be coming in and then going out again. For rain, it only goes in one direction, and for a golf ball, it really only goes in one direction, because here we have an initial momentum with the rain, but no final momentum. With the golf ball, there's no initial, but there is a final. So in both of those cases, there's only one momentum to consider. And so that's very useful. This is not what you would call one of the most critical sections, but it can be useful as background information.